Okay. Oh, I think it's on now. All right, who knows a storage joke? Anybody? Who, you know a storage joke? What's that? Did y'all hear that? There's a band called 1,023 Megabytes, but they can't get a gig. Simon Sharwood, everybody. Woo! Australia's own Simon Sharwood. So I do have a storage joke if you want another one that is better than Simon's. So when I was in college, and this will tell you how old I am, and actually later I'd like you to tell me whether you're surprised in a positive or negative direction. When I was in college, my roommate came in when Mac OS 6 came out. He was waving it in the air. Mac OS 6 is here. I wasn't a Mac guy, so I didn't know what was so exciting about it. So I said, well, what's so special about it? And he said, it has virtual memory. Virtual memory. Now I can have a really big RAM disk. Some people get that. Some people don't. So hey, you don't get that? That's because you're not Chris Millar. Oh, burned him. All right. Is the WebEx working? It is? Man, you guys are like, let me tell you, I present a lot. And it's hard enough to convince venues, whatever, people to get it in presenter mode, so you have a different thing on the screen than you do on the big screen. But to have it do this and have the thing work, that just doesn't happen. That just doesn't happen. So thank you. That's great. I don't know when we're ready to go. Nobody gave me the big thumbs up. I'm getting a big thumbs up from back there. Okay, smile, everybody. You run the risk whenever you're near me of being in a photo. I should have probably had you all sign a release. You also run the risk when you're near me, and the people who came to my Iowa Blender session know that you run the risk of having a sharp object thrown at you. So if you want a very, very awesome badge, come on up afterwards because I have a number of them. All right. Now y'all are going to think I'm some kind of bumbling weirdo or something. Okay. We're ready to go. We're ready to go. So I'm going to talk about virtualization. Have you guys heard of this virtualization thing? I think it's going to be big. Really, this is good stuff. But first, actually, before I do anything, I just want to say thank you to the VMUG people for bringing me here. This has been great. I always wanted to go to Australia. Now that I've been here, not so much. But before I got here, I really wanted to go here. And it's those drop bears. They scare me. Ever since I heard about that, I just don't want to be here. I hear this is the island where things can kill you, but it's not supposed to be the cuddly things. So thank you guys for bringing me here, despite the peril. And let me explain who I am. So I'm just some guy. I don't work for, well, I certainly don't work for the VMUG. I don't work for any company. I work for myself. I own my own company. And what I do is write and speak and organize events. That's what I do all the time. I used to have a real job. I used to be a Unix systems administrator, and then I was enterprise storage administrator for a bunch of big companies. I worked for a big oil company and a bank and learned a lot about enterprise storage and server virtualization and all that sort of thing. And over time, I started writing. I wrote a column in Storage Magazine. I started speaking at a lot of conferences about enterprise storage and server virtualization. And eventually it got to the point where I could do that for a living. And let me tell you, standing up on stage and drinking beers for a living is pretty good. Flying to Australia for a living? Not bad at all, you know. So I'm pretty happy here. So I'm a storage guy. I really am a storage geek, and I keep going back to storage. You know, it's all about the LUNs. But I also love virtualization. If you're a storage guy, I have pins here that say I heart. Oh wait, they look just like that. They say I heart storage. I also have ones that say I heart virtualization, or V12N, because virtualization is just too wide to fit on a badge. I'm also the Tech Field Day guy. Who's ever heard of Tech Field Day? Anybody? Oh, we have some hands. Thank you. I'm glad. So I'm the guy who organizes this Tech Field Day. For those of you who don't know, Tech Field Day gets independent technology thinkers and prognosticators and blognosticators and so on. Literally, we gather a bunch of people from all around the world. We fly them somewhere, usually San Jose, because those San Jose companies don't want to go anywhere else. And we organize a couple of days of meetings between the entire panel of Tech Field Day delegates and these companies. And they spend a couple hours with various technology companies, including half the companies that are out there. And we talk about what they're doing. And we have a real back and forth. And we stream it over the internet. And we put it up on YouTube. And if you go to techfieldday.com, you can see a lot of that stuff. It's all very, very honest. The companies love it because they love to talk to people like you. That's why they're here at the VMUG. And people like you like it because it's not just some company sales mumbo jumbo. It's people like you talking to them and interacting with them. So that's another thing that I run. And sometimes I do crazy stuff. One day at Tech Field Day, sometimes, all the time. Thank you very much. One day at Tech Field Day, we were sitting around the table talking about this new thing. You heard of fiber channel over Ethernet? Anybody heard of this? Yeah, fiber channel over Ethernet. You know what makes more sense than fiber channel over Ethernet? Fiber channel over token ring. And so we created a spec for it. We got some of the companies. I got to say, Nimble Storage, they launched at Tech Field Day, the day that we created fiber channel over token ring. And the CEO and founder of Nimble Storage, he's such a cool guy that he let us record an interview with him about fiber channel over token ring, and he committed that Nimble is going to support it as soon as there's user demand. CEO, baby. So if all of you demand fiber channel over token ring, I bet we can accomplish that. So this is the kind of stupid stuff that I do. But because, you know, who cares? What's the worst that could happen? And that's the end of my presentation. So, no, I pushed the wrong button. So I want to talk about virtualization. And did you notice the title of this? Virtualization is a stack of lies. You know where I'm going with that? Yeah, okay, maybe not. It is. It's a stack of lies, and I'm going to prove it. And I'm going to talk about overcoming the lies. And I'm going to talk about a lot of things I think that many of you may see parallels to the technologies and the products that you may have talked about today at the sessions, talked about with the vendors. Because basically, everything we're doing here is either creating lies or figuring a way to route around lies, figuring out a way to deal with the fact that we're being lied to. But I want to start with cloud. You know, because no discussion of lies should start without cloud. Virtualization is not cloud. In fact, virtualization is basically the exact opposite of cloud. And I don't mean technologically. Now, technology is great, but technology never made anything successful. Things are successful because of what they are, what they intrinsically are. Intrinsically, virtualization is all about compatibility, and it's backward looking. It's looking to the past and saying, how can I keep this old application running into the future without having it be a big pain in the butt to scale it or to move it or to implement DR or to do whatever it is that I'm trying to do with my infrastructure. Virtualization is all about compatibility. It's all about figuring out how to continue into the future. Cloud is the exact opposite. Cloud says, you know all that stuff? Forget that stuff. You know, you ever wonder how Twitter works? I wonder how it works whenever it's broken, but You know, Facebook and all these companies, Amazon, I mean, you can name a lot of real cloud companies. The reason that their stuff scales like crazy and your stuff doesn't is because their stuff was designed with that infrastructure in mind. It was designed to be a cloud application. They said, forget all that stuff. I don't care. I don't know. I don't want to know. I don't want to think about file systems. I don't want to think about operating systems. I don't want to think about CPUs and registers and memory and all that stuff. I want a platform that I can program a high level and that I can scale, and I can, you know, scale performance, scale capacity, whatever it is that they're trying to do. But basically, they jettisoned everything. Now, if you're sitting there thinking, well, but they run Linux, or they have disk drives and they have CPUs. Yes, they do, but they don't care about them. Did you guys see Facebook Open Compute? Did you see this announcement? They created this thing called the Group Hug. Could it be California? They created this thing called Group Hug, which lets them basically kick out Dell and HP and all the big OEMs. And in fact, Intel and AMD are now compatible in the Facebook environment. And they can use whatever hardware they feel like at the time. They care so little about the infrastructure that they have kicked out all the OEMs and decided that they'll just use whatever the heck they want to use whenever they want to use it with this new Group Hug interface. Because cloud doesn't care. But I'm going to go out on a limb and think that probably most people in real businesses with real applications can't throw everything out. Like if I said, tell you what, I want you to transition to cloud, okay? Step one, shut everything off and never turn it on again. Okay, you ready to do that? That's not going to work. So we need virtualization, because virtualization allows us to build a flexible infrastructure where we don't have to shut everything off. We can leave it running. We can leave it going. We can just put it on something that's more flexible, more scalable, more whatever. Well, how do we do that? What are we building? We're building a stack, right? We're building a stack. You've heard about companies talk about their infrastructure stack. But we're building a stack deeper than that. We've got a really big shovel. We're building a stack of lies, a deep stack of lies. You've seen charts like this, right? Pay no mind to the cloud in the middle. You've seen charts like this, right, where you've got a stack. You've got some storage, and you've got some servers, and then you've got some magical boxes that move around with, you know, vMotion or whatever it is. You know, oh, I'm using DRS. Well, how does that do it? How does that work? How could you take an application that is really tightly tied to an operating system, and an operating system that's tightly tied to a piece of hardware, and a piece of hardware that's tightly tied to a network interface and a storage interface and a storage array? How can you make that flexible? How can you make that move? Virtualization is what makes that happen. And this is really the fundamental reason that all of us are here today. This is the reason that a storage guy like me gets to hang out with cool server guys, right? Because otherwise, storage guys do not get to hang out with anybody. Virtualization fundamentally is abstraction. The idea that I feel like I'm standing here, but maybe I'm not. You know, it's the matrix. You know, maybe I'm actually somewhere else. Maybe my senses are fooling me. I like the Inception virtual machine that Mike mentioned at the beginning. It's kind of like that, you know. Abstraction says, I'm going to, you know, jack this guy up on stilts and move him around, and he's not even going to know what's going on. There's another part, aggregation. Now, server virtualization, VMware, this is not virtualization. This is not the end-all and the be-all of the word. I mean, I have said it a few times. I've used virtualization as a synonym for VMware and vice versa. But of course, virtualization has been around for a long time. IBM had mainframe virtualization 20 years ago, 25 years ago. Even things like RAID and SCSI are virtualization. I don't know if you know, let me take you back into the mists of time. Back a long time ago, there used to be thousands of hard disk drive vendors. Oh, he's a storage guy, all right. There used to be thousands of hard disk drive vendors, and each one had their own commands, their own protocol, their own physical interface, their own cables, their own everything. And if you bought this, you had to buy their controller and all this kind of stuff. That's how it used to be. SCSI was a way to abstract and standardize hard drives so that you could buy from any vendor and know that it supported a common physical interface, an electrical interface, and command set. ATA, same thing. Well, RAID is a way to take multiple disk drives, combine them together, and present them as a physical or a virtual disk drive. In a way, RAID is very, very, very much like a hypervisor for storage. And it uses this standard protocol. And then we go up the stack. So what happened after you had RAID? Well, you had storage arrays. Then you had fiber channel. What's fiber channel? Fiber channel is a fake, make-believe virtual bus. Because the SCSI commands still think they're connected to that little ribbon cable from back when, you know, except they're now connected over fiber and switches and all this kind of stuff. It's all virtual. And it's all abstracted. And it's all aggregated. And I did that again. And it's all simplified. And the reason that we as an industry do this again and again and again, we create this whole web of lies in order to make things easier for us, in order to make it possible to use storage from one company instead of another company, in order to make it possible to use multiple Ethernet network adapters, in order to make it possible to use CPUs from different companies. We buy all of these, we buy into virtualization because it lets us do things that we couldn't otherwise do. But that doesn't change the fact that I'm not talking to a real disk drive, and I'm not using a real ribbon cable. It's all fake. It's all virtual. It's all a bunch of lies. And this is what Windows does when you don't have the font installed. It changes it from a beautiful rubber stamp looking thing to a big clunky ugly thing. Thank you, Windows. Lies, lies, lies. It's all lies. This is all just a synonym for lies. Now, in the United States, we have a game that we'd like to call telephone, and I found out, happily, talking to people from other countries, that you don't call it that. Apparently, everywhere else calls it Chinese whispers. And you've played this before, right? You've seen this? It's a lot of fun. This is the stack of lies. This is what happens when your application is talking to a file system, is talking to a volume manager, is talking to an operating system, is talking to a hypervisor, is talking to a clustered file system, is talking to SCSI and fiber channel and a storage array controller and RAID and a disk drive. At every level, things are simplified and abstracted and made flexible and virtual and all fluffy like that. But what happens is exactly the same. At every level, essential information is lost. And this is the truth. And I'm not being, facetious here to say that the guys on the bottom of this stack have almost no information about what's going on in the environment. If you are a storage array vendor and you're trying to engineer a storage array for server virtualization, and all you have is fiber channel or NFS, you have no information about that workload that's going on above you. It's just random stuff. And you have to try to differentiate your product, and you have to try to figure out a way to make your product useful and do cool stuff and compelling and make you guys want to buy it. But you don't have any essential information at all. Imagine if it wasn't this way. Imagine if the storage array knew which application was writing to exactly which area and when and how important that application was and all sorts of things. Think of the cool stuff you could do. But we can't do that because we have to maintain compatibility. Above all, the paramount order of enterprise IT is maintaining compatibility. And that's absolutely essential for everything that VMware is doing in server virtualization. And the other companies that are doing virtualization for various things, desktop and so on, they all are focused absolutely on compatibility and making sure that things work. They must keep things working, so they have to translate and simplify. So what can we do? So it's not so bad, really, to lie. it gives you a positive result. I actually did had some fun here, and I did some research into the nature of lying. And it turns out that Plato, who you've heard of, right? Apparently, I mean, I am a technical guy, man. I didn't know this. Apparently, the guy spent a lot of his time talking about the nature of lying and talking about good lies and how some lies are beneficial to society, and it's okay to live the big lie if it helps all of us to get along. And what he was talking about was like stratification of classes and making the working class work without complaining. But, you know, essentially we're talking about the same thing with virtualization, right? It's okay to tell Windows that it's running on a plain, vanilla, generic piece of server hardware if it means that you can vMotion that, right? That's an acceptable lie because it benefits everyone. It's okay to tell Windows that there is no difference between a $100 Seagate bare hard drive and a $1 million EMC symmetric. Because otherwise we couldn't do the things we do with our environment. You know, it's a good lie, it's a beneficial lie. But the problem is that lies always cause trouble because you lose information. And if we had perfect information, maybe we could do things better. So virtualization gives us tremendous, tremendous benefits. But the problem is that I think a lot of people talk about the benefits of virtualization in the wrong way. So let me take a little segue here to basically justify that you should buy VMware and all this other stuff, right? Okay. Now, in the 90s, in storage, there was a big movement towards storage virtualization. There's all these storage virtualization products coming out, and essentially storage hypervisors. Nobody bought them. I didn't buy them. I was one of the people that they were trying to sell to. Why didn't I buy it? I didn't buy it because they kept selling it on operational efficiency. They kept saying, Mr. Storage Admin, if you buy this IBM storage tank for $1 million, you'll be able to provision storage like that, and then you can go and get a beer, you know? And I thought, that sounds good. I want to provision storage like that. I don't want to edit things manually, like on a command line. I don't want to do that. Operational efficiency is one of those things that is a wonderful, fabulous thing to have, but is almost worthless in terms of business value and making a budget to buy stuff. One of the things that I hear a lot when it comes to server virtualization is this guy, resource utilization. I'm sure that people will come to you and they'll say, why should I use VMware? I should use VMware because instead of having a rack of 10 servers that are barely running, I can have one server that's running all that stuff virtually. And that way I don't have to buy all the servers and I use less power and all that. Doesn't that sound great? Except what if I already bought those servers? What if I have an unexpected demand? There's all sorts of things. Resource utilization is incredibly valuable. But again, that's not why you really are buying VMware. Because if you just wanted to do resource utilization and efficiency improvements, there's a whole bunch of other hypervisors you could buy. You're buying VMware because of the cool things that it does, because of the advanced features that it has, because it's way ahead of everybody else technically in ways that are really beneficial to the business, things that really, really are killer, like DR. One of the dirty secrets of IT is that we spent 20 years in open systems IT architecting and rolling out DR systems that didn't work, right? I mean, I spent most of my enterprise storage admin, Unix admin career rolling out a DR plan that I knew step one should really be go find another job because there was no way we were going to get the business up and running again. I spent 6 days trying to recover a bank's entire IT infrastructure from tape in the 90s in this tank factory in Philadelphia. It was freezing. Step one was find some servers. Step two was figure out how to make those servers, get them up and running, and install the operating system. And step three was like restore all the data. It was a nightmare. At the end of day 6, we decided to check all the boxes so we could go home. Did we restore the data? Sure, the data's right there. Okay, did we get the application running? Yeah, Oracle starts up. You know, nothing actually worked. But it was because there was all this stuff that had to happen. But with virtualization, all these beautiful lies that we're telling ourselves actually benefit us. Think about how wonderful it is that you can take a running virtual machine and live, you can move that to a different piece of hardware that's totally different. You don't have to worry about the revision, the firmware revision of the card, right? You don't have to worry about any of this stuff. Think about how cool it is that you can set up a DR infrastructure, like a whole DR data center, and then roll things into it on demand. Now, of course, you still have to move the data, and you're still going to have to maybe reconfigure the network and worry about the applications. And it's not like a dream world. It's not like everything's fixed. But we at least have the potential to have everything work. You know, at least it's possible that we could have DR work without, where are we going to get a bunch of Sun servers? You know? No, that's the wrong model. So the reason I think that people really buy server virtualization products is because they're willing to accept the cost and the level of effort of implementing them, and even the lies and the interruptions and the inefficiencies. IT people hate inefficiencies, don't they? They hate overhead. You're willing to accept all that stuff because you know that it lets you do things that you couldn't otherwise do. So lies aren't really bad, but there are consequences to them. So basically, you know, it's okay. It's okay to lie. It's okay to lie to the operating system. It's okay to lie all around. But we have to think about how we're going to address that. We have to think about how we're going to cut through the stack. This is the least offensive picture I could find. How do we cut through the stack? Well, when it comes to storage, and again, I'm a storage guy, so I'm going to focus on myself because that's just a good thing to do. When it comes to storage, how we cut through the stack starts with improving communication. Imagine when you're playing, you know, Chinese whispers, you know, okay, I've got a daughter who basically cannot play that game at all. She's, you know, you whisper something into her ear, I don't know what goes on inside her head, but something else comes out from her mouth to the next person, and it has no relation at all to what she heard. Well, that's SCSI right there, okay. So we're going to name my daughter SCSI. And what if you could just skip past her, you know, like I really want the message to go through. So what if I could just like say it out loud, or you know, send a note or something. You know, this is what I really said. You know, VAAI. That's what VAAI is. VAAI is a note sent through the stack a little bit that says, "Oh boy, I know you don't have any information about what's going on here, but please just do this thing, and everything will work better." You know, I can clone my volumes if I ignore the I/O blender that I talked about earlier, and just, you know, just tell me what to do, and I can do it. VASA, it goes the same the other way. The abstraction of virtualization, and again, I'm not just talking about the hypervisor here. I'm talking about everything in the stack, controllers and array controllers and protocols and everything. VASA lets a little bit of information sneak up from the array to the hypervisor, or actually to the hypervisor manager, to vSphere, that says, I'm an old crappy array, don't use me. That's basically the purpose of VASA, is to give a mechanism so that vSphere will know, don't use this guy. Other things, you know, I talked a little bit in my previous session as well that most of you weren't at, but just bear with me here. Microsoft has a new thing called ODX, which allows Windows Server 2012 to communicate with the array. So from the server all the way down to the array. And again, it's not sending every piece of information. It's not clearing it all up and making it a brighter world. It's sending a few essential bits of information, like, I don't need this space anymore. You can delete it. You know, you can clear that up and put it in the free pool. This is how we address the stack of lies. And I think that what you find as you look around is that basically every new technology that VMware is working on and introducing is a way to address this fact that we have this massive stack of virtualization and simplification and abstraction. And information is not passed down the stack and up the stack. And pretty much all of the technical innovations that are happening now are ways of passing information up and down that stack and improving the effectiveness of the overall resources that we're using. So let's talk about this. Who says what? Well, VMware. What does VMware do? VMware looks at things as a hypervisor, from the hypervisor on out. Now, it's unfair to say that VMware is hypervisor-centric, even though I actually said that, didn't I? It's unfair to say that because I'm unfair. VMware is not hypervisor-centric in the fact that they believe that the hypervisor is the only thing that matters. They're hypervisor-centric in the way that means that VMware believes that that should be sort of the baseline. And if we're going to improve communication in the stack, we can go down from the hypervisor, we can go up from the hypervisor, but it's all going to come back here in the middle. And so if you look at a lot of the technologies that are coming, it's all about basically improving things back and forth into the hypervisor. Microsoft is different. Microsoft is focused on the operating system. Everything Microsoft does is a way to drive things and drive information and control and centralization and standardization into Windows. And it's funny because they're an application company, but they're not driving control and everything into applications. They're driving it all into Windows. Typical. Other companies, if you're an infrastructure company, you know, I'm sure that you probably talk to a storage company today. What is their way of dealing with the stack of lies? It's all about the storage, right? Everything's about the storage. Really, truly, that's the thing that matters the most. And everybody's driving information from the storage array up and down and in and out. Everybody cares about whatever it is that they do. Again, cloud companies are unique because they don't care about that stuff. They're just walking away from it all, and they just say, well, it's got to be running on something spinning and warm. So go ahead and do that, and I'm going to worry only about the application, okay? So that's sort of the perspective that you're going to see. And now, for each of these people, how are they going to deal with the stack? Well, there's basically a few things that you can do. I have three things that you can do to deal with the stack of lies. And most technologies and most of these, you know, technical strategies are one of these ways of dealing with it. Number one, you can just deal with it. You can say, okay, I know I'm being lied to, and I know that I don't have complete information about what's going on above me or below me or whatever it is that you're worried about. I'm just going to make do. I'm going to live with the information I have, and I'm going to figure out some way to make it work. My favorite some way to make it work is VXLAN, which basically says punt. Networking is a nightmare in mobile virtual machines, so I'm going to create a whole bunch of tunnels that I own that let me terminate network connections wherever the heck I want, and you network switches and all that, you can do whatever you want, okay? I'm just going to make it work. It's a very practical product. Another thing you could do is you could cut through the stack. This is the idea of VAAI. This says, okay, I know I'm being lied to. I know things are being simplified and abstracted away. So what I'm going to do is I'm going to figure out a way to get the real message to the guy underneath me, however low it needs to go. So, okay, you know, I'm a storage array vendor. I can no longer replicate LUNs because they're not consistent because there's no reasonable unit of granularity anymore in a virtual world because everything shares the same LUN. So if I replicate it, I'm just going to, it's just a waste. What I need is I need somebody to tell me exactly which blocks to replicate. That's what VAAI does, exactly that. So we can cut through the stack. We can bypass the middleman. In a way, Nicira, people are wondering about that, is this kind of thing. Nicira says we've got to deal with networking infrastructure. We've got to deal with networking infrastructure that really wasn't designed for a mobile virtual world, right? I mean, you know, basically it all comes down to ARP tables, right? So what we need to do is we need to have a better way of communicating with the switches themselves that says, you're no longer blind. I'm going to tell you some information. I'm going to tell you that I'm moving a virtual machine. I'm going to tell you the quality of service that this virtual machine does. I'm going to give you the ability to give me metrics back about how you're doing with the whole networking job. And this is why SDN is exciting. It's not because it revolutionizes blah, 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 blah. No, it's because it just improves the ability of network switches to switch networky stuff and hypervisors to do hypervisory stuff. Basically, it allows everybody to do their job, again, because it cuts through the stack while maintaining compatibility. Now, there's another thing that you can do, and this is kind of the cloud approach, and that says, forget it. I'm not playing this game anymore. And this is also the approach that VMware is taking with some of their products. It's interesting. VMware basically has two things going on. On the one hand, they're maintaining compatibility, and they're working really, really hard to maintain compatibility with existing infrastructure. And so they're coming out with things like VAAI that maintain existing infrastructure and let storage arrays work. And on the other hand, they're coming out with things like VDS, which is an entirely new storage layer that completely eliminates basically the need for a storage array, no SANs, no storage arrays, nothing. And in a way, Nicira could do this. And this is why people get all freaky-deaky about it, right? This is why the networking industry is all in a hubbub because, VMware is getting into networking, right? Why? Because they know that this sort of could happen. Now, it's not really likely to happen. And if you're VMware, you don't care if it happens or not. Think about it. VMware is playing both games here. If the networking world collapses and all their network OEMs fail, then the new world of SDN and commodity networks comes in and VMware owns it. Okay, that may not happen. So if that doesn't happen and they have to work with OEMs that make network switches and all this kind of stuff, hey, that works too. You know what? Because we got a protocol that lets us communicate more effectively and let the network switches work, and everybody's good. Same thing happens with storage. If VDS, VMware Distributed Storage, which is like, no SAN storage, basically, if VDS succeeds, it eliminates the need for an enterprise storage array and for fiber channel and even for NFS and all this stuff. Basically, you use local storage. It looks really cloudy. Well, if VDS succeeds and all those storage companies fail, VMware is good. But some of us may say, that's not likely to happen. That's not likely to work. Well, that's okay too, because VMware has vVol and and VAAI, and we're good. We're good with that. And so VMware is happy either way. And that's really what they have to do. Can you imagine if VMware just bet on one horse? Can you imagine if VMware went to market with the message, we're going to destroy all the hardware OEMs? How successful do you think they'd be as a company if they decided to do that? That really wouldn't work out so well. So it's good that they're playing both. They're playing both the cut through and the eliminate game here. So what will happen? Let me predict the future. Now, if I was a consultant, I should say, well, it depends. But I won't say that. I won't say that. Now, if I was a consultant, I should say, what do you think will happen? And then I'll just repeat that. Everybody's going to continue to add better communication. Again, as you see products come out, one of the coolest things about being just some random dude who doesn't work is that I have time to talk to all these new companies that come out. And I get briefed by a couple of companies a week that are still in stealth, and they want me to know what they're doing. I don't know why they want me to know, but I'm willing to take it. And so I listen to them. And so I hear the new developments that are coming up. All these new companies, networking companies and storage companies and server companies and all this virtualization software companies, what are they doing? They're building better ways to communicate information. So that they're basically either building cut-throughs or they're figuring out some way to destroy EMC and dance on their grave. You know, good on you. Do either one of those. One or the other is going to work. So go ahead. You know, and that's what they're doing, and that's their life, and so that's really, really cool. So maybe as you're thinking about what you heard out there, you know, think about this. Think about are they cutting through the stack, or are they changing things up? But either way, they're probably doing it in a way that's compatible. VMware is going to improve what they're doing. They're going to come up with ways of cutting through the stack. They're going to come up with ways of having new virtual revolutionary products. And what is Microsoft doing? Well, they're doing what Microsoft always does, aren't they? They're waiting and watching and moving in wherever they can and trying to figure out the best way to come in and take everything. But they're doing it from a Windows-centric perspective. So what's really going to happen? Again, it's so funny. I'll spend a day. I have day-long seminars on infrastructure for server virtualization, and I'll talk in depth about VAAI and all this kind of stuff. And at the end, somebody's like, ooh, I have a question. Yep, and I know what the question is, because it's always the same question. It's, my boss says Hyper-V is going to win. Is that going to happen? Okay, so let's just take the question. Who will win? There, that's the question, okay? You want to know who's going to win? I'll tell you who's going to win. All right. Whoever has the best way to overcome this stack. So I've just spent a long time describing why the stack of lies interferes with the capabilities, it causes overhead, it causes all sorts of problems. Whoever has the best technology to do that, to fix that, to cut through or eliminate the stack, that person has a huge technological advantage. Sounding good, right? Sounding good. Except that the best technology never wins, does it? Unfortunately, that's beta and VHS. Unfortunately, the best technology never wins. And then there's cloud computing. And what I think really is going to happen is, frankly, pretty much what's already happening. VMware is going to continue to work really, really hard to produce the best possible infrastructure virtualization they possibly can. And if they stumble, and if they don't innovate, and if they don't stay ahead, somebody else will come in and do the job instead. And it doesn't really matter, because somewhere out there, somebody's writing the next application, the next must-have business application. And that application will not run in a conventional infrastructure. It's going to run on cloud. It's going to run on a platform. But that doesn't matter either. Because think about it. How many mainframes are still running out there? You know, I actually, I did consulting, I have to admit it. I did consulting at a retailer in the U.S. who had bought another retailer, and their point-of-sale system still had the logo on the screen. Every store in America, a big store too, every store in America had a logo of a company that had been bought. And the reason was that it was a mainframe application that they couldn't figure out how to change the logo. But they continued to use it because the mainframe was indispensable, because that was the only way that they could possibly run their business. Massive, massive retailers. Mainframes aren't going away. A lot of the enterprise IT applications that you use that need VMware, you know, like everything that we're here to talk about, those applications aren't going away. And they're still going to need VMware. And they're still going to need x86 servers and storage arrays, or maybe not storage arrays, depending. But the point is, they're still going to run on virtualization and Linux and Windows and so on. What's going to happen is there's going to be another application and another application and another application. And those are not going to run on this kind of infrastructure. So basically, don't worry about it. You have a job. You know, cloud is not going to eliminate your job. But it's coming in. And there's people working on something that we can't even imagine what it is, but somebody's going to walk into your office someday and say, I need to get this new application because this is what all the cool guys have and all the other businesses have. And you're going to have to support it. But you'll still have VMware. So that's what's going to happen. Now, that's what I've got. I'm Stephen. I'm glad that you guys listened to me. I hope that you heard something in here that was at least moderately valuable to you. At least you got a good storage joke out of the thing, right? And thanks, Simon, for the good storage joke. And I appreciate it. Do we have a couple minutes if anybody wants to ask anything or say anything, or should we just get out of here? I don't know. Nobody's giving me a thumb up or a thumb down. So does anybody have any comments or questions? Or come on, somebody has to say who's going to win. Laverick said that in Sydney. So nobody has anything to say. All right, well then I'll take that. Thank you. Oh, no, I'll take that. Who's hooting and hollering? That was you? Okay. So, and I do. I have fiber channel over token ring badges. I love virtualization. I love storage. So if you'd like a badge, come on up and get one. I've also got my business cards up here, so if anybody wants to keep in touch with me. And now, I think it's time to do some giving away. Giving some love.
Giving some love. Are these on? Yeah, cool.
You don't sound like Australian.
I'm not Australian. Oh, I am, actually. But anyway, it's a complicated story. You got me on stage saying that now. That's terrible, isn't it? Okay, so look, we're just going to wrap up today. I just want to thank everybody personally for coming today. It's been a fantastic session. I hope you all got something out of it, technically and also from a networking perspective as well. It's not often we get all these people together, so I really appreciate you coming today. I wanted to thank the Hands-On Labs, the Pivot 3 guys. Really appreciate them putting that on today. I believe that the Hands-On Labs will be available beyond this session, so you'll still be able to log in and actually access Project Knee if you've got usernames and passwords. I believe some people didn't get them, but they will come, so you will still get them at some point. So I also wanted to thank, I guess, are the VCDX guys still going on, or is that all? Oh, here you go. So Michael Webster, just want to thank him for doing the VCDX bootcamp. Did you give away the book? Yeah. Where's mine? I'm joking. Yeah. Yeah. Thank you very much, Michael. So Michael flew over from New Zealand today to present that, and we really appreciate it. And thanks for the other VCDXs who were involved as well. I know Frank Fan was there. I'm going to call you out, Frank, and Josh Hodges as well. So we've got what would you call? You know, have a mob of kangaroos. What do you call when you have a bunch of VCDX guys? Yeah. Trouble. A pod, is it? Yeah. So thanks, guys. Thanks for your support. We really appreciate it. Yeah. I also wanted to thank the community session guys. I don't know if you're around. Is anybody here who did a community session today? Do you want to come up, guys? Do you want to come up? Because I just want to say thank you. I hope there's not more than 4. Come on, Josh. Come up. You won't do it, eh? Come on. So look, I've got a couple of t-shirts. They're all like one size. So just to say thanks to you. And you. Come on. Hang on. Hang on. I thought you might need another t-shirt. Oh, very good. Thanks, yeah. So I just want to if you can give these guys a round of applause because they've done this out of their own